Solving equations with exponents and roots. When we're solving equations with exponents and roots, we need to remember that powers and roots are inverse operations. They undo each other. Okay? So if we're solving equations involving x squared, x cubed, or x to the fourth, or if we're solving an equation involving roots, the square root of x, the cube root of x, the fourth root of x, what we're going to be using are the inverse operations to solve those. So if I want to solve the equation x squared equals 25, I need to use the inverse operation of squaring, which is square rooting. So to solve this, I square root both sides of my equal sign. What I do to one side of any equation, I always do to the other. Well, I know the square root of x squared, they undo each other, so all I have is x. And the square root of 25, we know is 5, because 5 squared, or 5 times 5, equals 25. But in this situation, there's another possibility. I also know that negative 5 times negative 5 equals 25, so x could also be negative 5. So we have two solutions, 5 or negative 5. And we should always check our work. So 5 squared equals 25. That's good. And negative 5 squared equals 25. That's good. If I want to solve the equation x to the third equals 27, the inverse operation for cubing is cube rooting. So I cube root both sides of this equal sign, and I end up with the cube root of x to the third is just x, and the cube root of 27 is 3. I can check my work. 3 to the third power, 3 times 3 times 3 is 27, so that checks. If I have x squared equals 7, again, the inverse of squaring is square rooting. I do it to both sides of my equal sign. But this time, 7 is not a perfect square. So I can say that I have, as an exact answer, x is equal to the square root of 7, or x is equal to the negative square root of 7. Okay. Another way to write it is x equals plus or minus the square root of 7. If I wanted to check my work, well, I know the square root of 7 squared is 7. Okay, and the negative square root of 7 squared, well, let's see, the negative times a negative gives us a positive. Square root of 7 times square root of 7 is 7, so that checks. Okay, working backwards, we can solve equations that have roots. So if I wanted to solve the square root of x equals 5, the inverse of square rooting is squaring. So I would square both sides of that equal sign. The square root of x squared is just x. The square and the square root sign go away. Oops, I meant to square the 5 too. And 5 squared is 25. We can check our work. The square root of 25 is indeed 5. Checks out. Okay. If I have a fourth root, well, the fourth root's inverse is the fourth power. Okay, so I would need to raise both sides of my equal sign to the fourth power. On the left side of my equal sign, the fourth root and the fourth power are inverse operations. They undo each other, so I'm left with x. And 4 to the fourth power, 4 times 4 times 4 times 4 is 256. If I wanted to check this out, I could use my calculator. The fourth root of 256 is indeed 4. Okay, one more example. If I have the cube root of x is equal to negative 3, I want to do the inverse operation of cube rooting, which is cubing. So I cube both sides of my equal sign. Well, on the left side, the cube and the cube root go away, and I have an x. On the right side, -3 cubed, -3 times -3 times -3 gives us -27. If I want to check myself, the cube root of -27 is indeed -3. Always remember, when you're working with powers and roots, whatever the root is, the inverse is that power. Whatever the power is, the inverse is that root.